going to actually kind of change gears a little bit today and later in the week as well. We're going to talk about some different kinds of probability distributions. And what do we, when we say distribution, we just kind of mean a grouping of numbers. And these are, we're going to talk about two today, a different one later in the week. You have talked about a set of distributions, probability distributions already, because you talked in Algebra 2 about something called a normal distribution. And all it is a collection of data that gives you probabilities of certain shaped data. So if something is considered a normal distribution, then you can use this probability model to answer some questions. We're going to talk today specifically about the binomial. We may or may not get to geometric today. And we're going to talk about a binomial situation, and it has a certain kinds of criteria to fit it. And if it's considered binomial, then we have these probability models that will answer questions for us. Now, in the old school days, we had tables where we had to look up the tables. Kind of, I don't even know if you guys even know this, but back in the olden days, it's pre-Miss Mackert, they used to have trig tables too. Like they didn't have the sine, cosine, tangent buttons on the calculator. You actually had to use trig tables. Well, they used to, right, and then they also used to have logarithmic tables and all kinds of things. But because of technology, those things have been increased in advance. And our calculator actually has both the binomial and geometric models already in the calculator, and also has normal as well. So lucky for us, we're technologically advanced, and we don't have to use the tables, and then we're not going to. And AP actually allows us to not use them. So yay. So here we go. So what does it mean for something to be binomial? So this is what you need to write down. This is pretty important, okay? There are 4 criteria to make something a binomial distribution. And when you read a question on a test or a quiz or anything like that, you have to ask yourself, could it be a binomial situation? Because if it can be, we can answer the question quickly using this model. We have actually already come across several binomials. We just haven't we haven't solved it using this formula. And there are reasons why we want to, and we'll look at that in a few minutes. Here are the 4. The first one, are there independent trials? Okay? For example, if I have the catalytic converter example on your last test, okay? Is the fact that the first one's defective independent of the fact that the second one is defective? They are going to be considered independent trials. Okay? 2 possible outcomes. It's either defective or it's not defective. There's only 2 possible outcomes that could happen. You have 2 probabilities. It either happens or it doesn't happen. The probability is the same for each trial. So think about those catalytic converters again. The probability that they were defective on your test was it 6%? Is that right? Or I forget. Let's say it was 6%. Okay? It's the same. For every trial, it's considered the same. And you'll have a set probability. And then the last one is that this number of trials is actually fixed. So I think on the test we had 4, didn't we? We had 4 catalytic converters that were being picked. How many, so that would be our question. So that would be a binomial situation. We didn't solve it using that because we had a different question. It was like, I think the first defective one was on the 3rd trial, right? That's actually considered geometric, not binomial, but very similar. So everyone have those written down. Very important. You ask yourself those same 4 questions over and over. Now, if you look at your formula sheet, this is the formula for, I think maybe that this is the book. I think the book uses N's and X's. I believe that AP uses K's. Is that correct? Can I see someone's formula sheet real quick, just so I can make sure it's K, right? So I think they use a K here instead, right? But and it's N minus K, sorry. PK, then N minus K. So they just use K rather than X, that's all. Okay? But the same thing, it's not a big deal. But what we need to really pay attention to is, because you can use your formula sheet at any time, on any test, any quiz, it's definitely not required that you memorize the formula. Okay? I'm not about memorizing formulas. I'm about how to use them and knowing which one to use. So in this particular situation, again, you can change this to a K to correspond to your formula sheet. I'm just looking at what the book does. N represents the number of trials. Didn't I say just a minute ago that we have to have a set number of trials? We have 4 catalytic converters, right? So that is your N in the formula. So let me highlight where that's going to be. So if N is a number of trials, this number is your N. Okay? The probability of success, now that's important because there are going to be probabilities of failures as well, because it's success and failure. Every binomial situation is either one or the other. There's 2 outcomes, and that's it. The probability of success is here. I believe on your formula sheet they don't even use Q. They just use 1 minus P. Is that correct? So that actually, to me, makes more sense because that is what Q is. Q is just 1 minus P. So these are just the complements of one another. Okay? X happens to be the number of successes in whatever trials we have, or K in your situation, on your formula sheet. Okay? Now, we'll get to mean and standard deviation of a binomial situation in a little while. These formulas also happen to be on your formula sheet. If you have a binomial situation, I could say, what is the mean? What is the standard deviation? Double check me, but those are there. Are you correct? On the formula sheet in the middle there. It should be right under it. Okay, good. Just want to make sure. Again, nothing you need to memorize. The missing formula is this. Do you agree? It's missing. What the heck is that? N, that is red, N choose X. So we need to discuss what does that mean, N choose X. Back in Algebra 2, your teacher should have talked to you about permutations versus combinations. Do you remember that from last year? Okay. Combinations is what this is. This is N combined with X. Okay, N choose X. Sometimes we write it this way. Have you seen that? You absolutely can, but the notation that AP uses is this bracket notation. To me, it looks like a matrix almost, but it's not. They are parentheses. This does not say N divided by X. This is read N choose X. It is the same thing as NCR, and your calculator actually has this calculation already on it, which is kind of nice. What I am going to show you is the derivation of the formula, and here it is. Do you remember what the exclamation points mean?
Factorial.
They are factorial. And what a factorial is just 3, like let's say 3 factorial is just 3 times 2 times 1, which in this case is 6. 4 factorial would just be 4 times 3 times 2 times 1, etc. Okay? So, well, you're not going to distribute it. Okay? I will probably, in this class, never ask you to find these combinations by hand. I'm simply giving you some background information. That's really all I care about right now. Okay? This is the formula. Do I ever ask you to use it? Probably not. But here it is in case you were interested. What we're going to do is we're going to actually calculate this here using the formula, or using the, we're going to find this part of the formula using the calculator. Okay? So let's practice that for a minute. Let's do it once the long way to make sure we understand, and I'll show you the shortcut on the calculator. So for example, let's try 10, let's say, let's do our catalytic converters. Well, we'll do 10, it's fine. 10 choose 3. So let's say we had 10 catalytic converters. What is the probability that 3 of them will be defective? Okay? So 10 choose 3. It's written this way. Let's just practice what would happen using the formula. This would be 10 factorial divided by 3 factorial times 7 factorial. Are we okay with that? Where'd the 7 come from? 10 minus 3. That's just what it tells me to do here. Okay, that's what the formula tells me. So we're going to go, I'm going to try to use my online or my calculator here just because I know so many of us are at home today. So on here, we're simply going to, let's go ahead and find the we'll do 10. Do you know where factorial is on the calculator? It's under math, and you go over to PRB, and factorial is option 4. So we have 10 factorial divided by, now I'm going to go ahead, is it okay first if I just do the fraction thing? Because I'm a big fraction. So 10 factorial, just because I want it to make sure I come out correctly. And then the denominator, we have 3 factorial. Have you ever done that fraction thing before?
Yes.
I can show you where it is if you're interested. So the answer is 120. Do you want to know how I got the fraction? You go to alpha y equals, and then it says n/d. That just means numerator denominator. Do you see it there? Alpha y equals n/d, numerator denominator. You see it there? Okay. So that is the answer. Using the formula, awesome. Now, what we also can do, because this says 10 choose 3, we can type into the calculator this shorthand notation. It's already got the formula plugged in. We can just tell the calculator what is 10 choose 3. So to do that, you simply say 10. Then we find this NCR button that Sammy was referring to, and that is found underneath math, probability, NCR. And then you hit 3, and you should get the same answer, okay? So that is just a shortcut on how to find the first part of the formula, okay? Any questions so far? And again, will I ever ask that you do it with the factorials? Probably not. Now, there's no probably. I never would. If I did, it would be extra credit, but I'm not going to do it, okay? That's just background information. So we know how to find the first part. Then you would just take that and multiply it times the second pieces. I think we should probably try one, okay? So let's look at a situation. Here's an example, okay? Let's make sure that this example is a binomial situation first. I'm rolling a fair die 20 times. What's the probability of rolling exactly 1, 3? So what are our 4 criteria for a binomial? What's the first one? Is it independent? Every time I roll the dice, is it independent of every other roll? Yes. So I have independent trials. What's the second criteria? 2 possible outcomes. What are the 2 possible outcomes here? 3 or not a 3. Perfect. So I have a success or I have a failure. I've either rolled a 3 or I haven't. What's the third criteria? So the same probability for each trial. Is it rolling a 3 have the same probability for each trial? What is the probability of success? 1/6, because 1 out of the 6 sides of a dice has a 3 on it. So I have a probability of a success of 1/6. And what's the fourth criteria? Fixed number of trials. And do I have that here? I've rolled it 20 times. So it is a binomial situation. So let's use our formula to come up with it, okay? So let's decide what our N, our P, I tend to use X. Are you okay with that, or would you prefer me to use K since that's what your formula says? You want me to use K? Fine. N is what number? Let's assign the numbers. 20. What's P? 1/6. That's your probability of success. And you can go ahead, what is that, 0.16 repeating? Double check me. Okay. So but since it's not an exact probability, we'll leave it in fraction form. And then what's K? K is 1. It's the number of successes. I want 1 3. Okay? I don't want 2 3s. I want 1. Don't let the 3 bother you. It could be 1 blue hat. It could be 1 purple jelly bean. I don't, you know what I'm saying? Don't let the 3 is just, has nothing to do with it, really. I better check that, right? All right, so let's plug in our numbers. So it's n choose k, so it's 20 choose 1. Remember, it's choose and not divide by. And then we have p 1/6 to the what power? Look at your formula. 1/6 to the first power. Oops, I'm going backwards. And then we have 1 minus 1/6, or 5/6. If you want to go ahead and just write 5/6, that's okay. To the 20 minus 1, which is the 19th power. Okay? Because k is 1. That's a k. P was just 1 minus p. These two, Sammy, will always add up to be 1. They're complements of each other. So I'm going to pause the recording for a minute. I want you to plug it in your calculator and tell me what the probability is. All right, so 0.1 something? 0.104. Did anybody get a different answer so we can talk about how to get it, or we're okay with how to plug it in? Honestly, it's just plugging it into your calculator, right, and knowing what buttons to push. Okay, so here's a key word in this question, exactly. Because we're about to do some that aren't so exact. For example, this situation. If I roll a fair die 20 times, what's the probability of rolling at most 2 3s? So we have to be careful here because it's the same situation because it's already binomial. We've already checked the conditions. We know it is. By the way, from here on out, you're going to hear me say, have you checked the conditions from here until May? So these are the first set of conditions we have checked. There are probably about 20 different sets of conditions we're going to have to memorize. I hate that word. Okay, are we ready? What's the key word here? At most. So we have to decide for ourselves what at most means. So it considers the 0 case, the 1 case, or the 2 case. So we'll have to take into consideration all of them and do what? Add them together. Perfect. So this is at most 2 is the same as the probability of 0 or 1 or 2. So that's going to be, so we'll have the same NPK thing, but the K is going to change. The K is going to be 0, 1, or 2. Would you agree? And depending on the situation we're talking about, your N is still 20 and your probability of success is still 1/6. So what does this look like? This looks like 20 choose 0 times 1/6 to the 0 times 5/6 to the 20 plus, there's a shortcut eventually. I'll show it to you eventually. There is a shortcut. You know there's got to be. What if I said we're going to roll it 20 times and I want to know the probability of at least 19? Well, we'd be adding up a lot of junk, right? There is a shortcut, I promise you. We'll get there. So at this time, I'm going to have 20 choose 1 also. And then we have 1/6 to the 1. We just did this one, didn't we? All right, and then the last case is 20 choose 2, 1/6 squared times 5/6 to the 18th. And we'll add those together. Yes, ma'am. Sure. Okay. So add these up and tell me what you get. So this is the long way using the formula where you have 20 choose 0, 1/6 to the 0, and whatnot. I quickly got the answer using my calculator using 0.3829. I'll show you how to get there in just a minute. But you should have gotten that using the formula as well. Okay. 3, 2, oh, thank you. It does round to 7, though, not 9. So 0.3287. Thank you, Brenda. right? So let me show you the shortcut. You want to know it? Because now, the reason why I kind of initiate this long way around using the formula is because on the AP exam, they're not going to care how you calculate your answer, but I have seen on some of multiple choice questions they've released or other things that they show the formula. So you have to know with the formula what numbers mean what. Okay? So you have to know that this number in the formula does mean the number of trials. This number means the number they're talking about. And the 1/6 is the probability of success, those kinds of things. So it's important that I show you the formula and the class work that we're going to do that I'm going to actually grade. So I think we need an easy grade. I'm going to give this to you. I want you to show me the work using the formula as well, but I am going to show you the shortcut. So if I wanted to find these answers with a calculator quickly, let me just kind of pull it up here. Okay? On your calculator, we know how to find 20, choose 0, and 20, choose 1. I've showed you where that is. The calculator also has the binomial formula stored in. So it will allow you to answer the questions automatically. What you have to remember, and this is the key part, if you're going to use the shortcut, it only considers less than, okay? Which is pretty important because it gets confusing if you don't remember that part. Is this a less than situation? Yeah, it's 2 or fewer. Wouldn't you agree? It's 2, 1, or 0. It will only do less than. I will show you how to compensate for that if you have a greater than situation. So what you need to do is the binomial distribution is found under distributions, which is second vars. So find it on your calculator. Second vars. Yes, sir. Can you what? I just can't hear you. I don't have any batteries to hand out. I'm sorry to students. You can borrow one of my calculators if you'd like. Now, I don't see binomial here. There are lots of distributions. You can see normal. We'll eventually use that one. But if I scroll down, you'll see 2 different binomial situations. Hang on. The binom PDF stands for probability density function. That means the exact situation. So we could have used that to find exactly 1, 3. When you have binom CDF, C stands for cumulative density function. So that's when we're talking about the less than situation. So in this case, we will use CDF because CDF is talking about more than 1. We're talking about 2, 1, or 0. So we're going to select that. It's going to ask us some questions. It only asks us these questions if you have the newest operating system. Older operating systems, this screen did not pop up. So we've kind of we've come a long way, which is nice. We're going to plug in the number of trials. This is just our n. Our n is 20. P is the probability of success, which we know to be 1/6. Oops, 1 divided by 6. And then the x value is where we start and less than. It does include that number. So if I put a 2, it will be 0, 1, and includes 2. Okay, that's important. And then we'll paste. In this case, it's 2 because we're including 2. And then we hit enter, and it gives us the answer. So it already has the formula built in, which is kind of nice. We just need to know how to use it, okay? So the question becomes a little bit more difficult if I said more than 2. Would you agree? What is that answer going to be? Huh? Yeah, that's a shortcut for this particular case. These are complements, aren't they? More than 2 and at most 2 are complements, so it's just 1 minus 0.3287. But I'm going to change it up because I want to make it harder. Let's change it to 3. Well, 3 threes, that's too confusing. Let's do 4. So I want more than 4 threes in my 20 rolls. So let me think about what that means for a minute. I tend to draw a number line so I can see. What I mean is that we can have 4 threes, we can have 5 threes, or 6 threes, or 7 threes, or 8 threes, or 9 threes, all the way up to 20. You want to add all those together. Whew. That would take a while. We'd probably be here till Thursday, right? So what are my choices? So let me show you how I kind of visualize this. I can have 0, 1, 2, 3, 4, 5, ... to 20. Would you agree? Those are all the possible outcomes if you want to think about it. What do I want? I personally want more than 4. More than 4 starts here and goes in this direction. Would you agree? I strongly encourage you to draw this out in the beginning because this is a nice visual that will help you set up the formula. I really am going to encourage you to do that. I might even require it. Because now we can use our formula or what we know to come up with the answer. Isn't 5 or more the complement of 4 or fewer? And doesn't our calculator calculate 4 or fewer pretty quickly? Which is what I want. So really what we're going to do here is the answer to this question is 1 minus binom CDF, and I am okay if you use this shorthand for now, 20, 1/6, 4. Where'd the 4 come from? Because that's 4 or fewer. It's the complement of what I'm looking for. I tend to circle and draw the arrow in the direction of what I'm looking for. If I'm looking for something less than, I don't have to use the complement because the calculator automatically does that part for us. If I am looking for a greater than, I do have to use the complement. And you have to be careful because it's 5 or more, we have to put a 4 here. Okay? So tell me what the answer is. 0.7687? All right, let's try it. 1 minus, for those of you watching the recording, I am doing this off to the side. 0.231 is what I got. Okay. Yeah, you forgot to subtract it, right? You want the complement. 1 minus. You can do it all at once in the calculator, actually, which is what I did. Yes. You always use the CDF if we're talking about a greater than or less than. PDF is when it says the word exactly. So for example, well, exactly, we could have done binom PDF here. I'll show you. Rather than use the formula, which I showed you the formula, right? I could have just as easily done, where'd it go? Binom PDF, and we would have done 20, 1/6, and 1. I keep doing 16. 1/6 doesn't want to divide. There we go. And then 1, and we should have gotten the exact same answer. Okay? So it gives you the same exact answer as the formula does. Okay? It's the CDF when you have to add several of them together. Okay? Good questions. How do we feel about this so far? Think we should practice with it a little bit? All right, so we only have about 35 minutes, so I'd like for us to try to answer these questions. I do want you to use the formula on the first 10, and then on the bottom, so 1 through 10, I want you to use the formula, because they are all exactly, actually on all the exactlies. I'll just say it that way. Use the formula on all the exactlies just for practice. If it's greater than or less than, fewer or whatever, you can use the shorthand version, the short version. Are we okay with that? But you need to show me your work. You need to show me what you did. So for example, I am looking for, it erases and highlights. That's interesting. I'm looking for this and this. when it says the word exactly. If it says greater than or less than or at most or whatever, you can show me this and the answer. Are we okay with that? But you need to show me what you typed into the calculator, Zachary. Don't just give me an answer. All right? When you subtract it from 1, it's a greater than. If it was a less than, it would just be the binom CDF. Okay? If you are out today and you are watching this recording, you need to stop by and come and if I don't have an electronic copy, and get a copy of the classwork. I could scan it and put it online. Oh, I could take a picture of it. Maybe I'll try that. I'll try to do it that way. So I was able to get an electric copy of this classwork assignment, so you can find it online in the probability section of School Fusion. So I won't give you an additional homework tonight, but what that means is that when we get to geometric distributions and normal distributions on next class, that'll be Thursday, you'll have some binomials mixed in there as well. So you'll have to decide the difference between them all, okay? So just kind of keep that in the back of your mind. But just go ahead and finish this for homework, bring it back. It is graded. It's not a traditional homework assignment. It's going to be a graded assignment. Make sure you're showing all of your work, and then bring it in next class, okay?